This is what we have to understand. The content delivery will be entirely different. There is no doubt in that. Those who have got a PhD degree in electromagnetic fields definitely will take and will give many number of examples, many number of case studies to the students rather than the staff member who is taking as such without any research experience. So competency is second part. Third part, what level you are giving the syllabus to the students, at what knowledge level. Whenever we talk about the knowledge level, we have to understand the Bloom's taxonomy. As you know, all of you know, definitely Bloom's taxonomy, there are 6 number of levels, right from understanding, remembering, applying, analyzing, evaluation, and finally creating. All these, there's 6 number of verbs are verbing version of your Bloom's taxonomy, K1, K2, K3, and so on up to K6. There are 6 number of knowledge levels. We are normally in engineering affiliated colleges. If you look at even the autonomous colleges, they are they are delivering the content maximum in undergraduate level. They are giving the syllabus maximum of K3 level. Knowledge level is K3. Till applying, we are giving the delivering the content. Whereas the same syllabus in IIT Madras, they are giving the content in the level of K4 or K5. In the analyzing part also, the students will be capable of analyzing those problems related with electromagnetic fields. So this is what the difference. Now, in the knowledge level itself, how depth you are teaching to the students. At the top level itself, or horizontally top level, or vertically you are getting into, depth is more. This is what the basic understanding we have to improve the quality. Very simple understanding, but a lot of things have to be done. So how can you find out how good? For example, I am giving the first unit is, for example, I can take any other simple subject for mathematics. The first unit is some addition, subtraction, something like this. This is the first unit. The staff member, by simply looking at the syllabus, they will be taking the addition, three digit addition or 4 digit addition they can have, or subtraction also like that. Multiplication, 4-bit multiplication, or not bit, digit, 4-digit multiplication, or 5-digit multiplication. They can have decimal also. So who will decide which extent we have to teach to the students, and to which extent we have to ask the questions to the students for assessing the students. So this is the basic mechanism we have to have this learning. So if you frame this syllabus, the syllabus is a guideline or abstract. So based on the title, the 2 different staff members can be taking the same syllabus to 2 different sets of students. In that case, the first staff may be good in competency. They can take, or he can take a very good, even giving the real-time scenarios, they can handle the session. Whereas the second staff, since they have given only addition, subtraction at the abstract level, so they will be taking simple version, or a simple 2-digit addition, or 2-digit multiplication, or 2-digit division, something like that. They are taking the class. Whether this is right, this is the first question. Whether this is right. The same syllabus, one staff is taking the depth level, it is entirely, he is getting into root level, whereas another one staff, he is taking the same syllabus at the top level. Top level in the sense they are taking very simple problems and simple examples. They are not even handling the real-time scenarios, like some scenario-based questions he is not asking. Then how can you evaluate the student now? In that case, we have to evaluate the students. The evaluation will also be different. So, whoever is taking the class, delivering the content, whoever is assessing the students, they have to have a clear idea how much we have to take, at what level we have to ask the questions to the students for evaluation. This is what it should be clearly mentioned in your syllabus itself, but the syllabus is totally abstract. So in order to support the syllabus, how can we deliver the content? We need to write the course outcomes. by giving the clear course outcomes, our learning or the students learning or student classroom will be a flipped classroom. So for example, the question levels based on the knowledge levels, whatever the knowledge level you are mentioning in that CO, it will be changing the entire scenario of the syllabus. The quality is entirely changed based on this CO. So CO only has to give the idea how depth we have to take the content, and how we can evaluate the students or assess the students, at which level we have to evaluate or assess the students. So for this we are using the course outcomes. So if you write a clear course outcomes, then it will be better and it will improve the quality over a period of time. Definitely it will improve the quality of the students in analytical part. Analytical sense, it will be giving very clear idea. So your course outcome must be very clearly mentioned, what level we have to take and what level we have to assess the students. This is what the meaning of writing course outcomes. So if your course outcome is clear, then everything will be clear. If your course outcome is quality wise better, your student output will be definitely good. This is what the expectation. So the course outcome should be SMART. SMART in the sense S for specific, M for measurable, A for achievable, R for time bound, and all this. SMART, SMART, SMART. Specific, your course outcome must be very specific. What are the topics we are going to have? What are the... So in the course outcome structure, look at the slide now. There are 4 parts in the course outcomes. One is action verb, second is knowledge, third is condition, fourth is criteria. 4 elements in each and every course outcome. When we write the course outcome, these we have to understand. These are all the 4 factors we need to include. 2 factors are essential mandatory factors. 2 more factors are optional factors. Mandatory factors are action and knowledge. Optional factors are condition and criteria. In your basic level, all of you can understand when we teach the students any subject, we have to be very clear what kind of cognitive level we are going to teach, or affective level, or psychomotor, what kind of activity we are going to initiate in the classroom to deliver the content. Hello. This is what we have to understand. So the action and the knowledge, these 2 are main parameters, are mandatory parameters, and optional parameters are condition and criteria. For each and every course outcome, we should have these 4 parameters. We can see one by one. In the action part, action verbal part, we can, based on the action verb, normally we are deciding.
The slide actually first slide, sir.
I am moving. One second.
Course outcomes and இது வரைக்கும் போனீங்கல்ல.
Now?
இல்ல sir, வரல sir. Participant kindly confirm. First slide மட்டும் தான் தெரியும்.
Yes sir, yes sir.
Yes sir, yes sir. First slide only shown.
Now I am in 4th slide. I'll reshare again, otherwise
yes sir. Full screen பண்ணிட்டு பண்ணி பாருங்க. Sorry sir, I am parallelly attending the space at
okay.
The webinars.
Okay, what are our course outcome now? Is it visible to you?
The first
No
slide
sir. No. Slideshow, you can put in slideshow mode.
Slideshow only. In slideshow only I am giving. Then why it is not coming? And I am in slideshow only.
Sir, screen stop பண்ணிட்டு
stop பண்ணிட்டா
க்ளோஸ் பண்ணிடுங்க அந்த PPT க்ளோஸ் பண்ணிடுங்க.
Stop. Share the screen. Now I am moving to PPT. Now, okay. Now is it visible?
Yes sir.
But not in full screen mode. That
full screen. Full screen. Full screen.
full screen போட்டேன்னா வரமாட்டாங்கன்னு நினைக்கிறேன்.
ஓகே சார்.
இதுலயே
Okay, okay.
போகட்டா இதுலயே போகட்டா?
போங்க போங்க.
Okay. So this is what previous slide I explained to you. There are 4 parameters in every course outcome. One is action, another one is knowledge, third is condition, fourth is criteria. You keep it in your mind. AKCC, A for action, K for knowledge, C for condition, C for criteria. AKCC are the components of every course outcome. Action is based on the verb, action verb only, we can easily find out in which level, your knowledge level, the particular course outcome has been written. And the knowledge is, we can understand. I'll be giving 1 or 2 examples here for each and every variety so that you can understand the condition. In some cases, we can concatenate 2 action verb also. For example, in this this is for control system, draw body plots for the given dynamic system and determine the gain and phase margins. So in this, there are 2 action verb, one is draw, another one is determine. So we have to, the students able to, after completing this particular unit or particular syllabus, to student have to complete, able to draw the body plots, and they can easily determine the gain and phase margins of the system. This is what we can, like this, we can concatenate 1 or 2 action verbs. This is also possible. So the first point is action verb. So based on this action verb, normally the knowledge levels are calculated. Knowledge level is for UG graduates, according to my understanding, the UG graduates, K3 is the maximum knowledge level for theory courses. For theory, it can go up to K4, K5 for practical, I mean laboratory and project courses. It can extend up to K2, K3, K4, K5 also we can reach in 1 or 2 courses in the entire undergraduates. According to me, in 6th, according to me, in UG, K6 is very rare. Few institutes across India teaching the content to K6 level in undergraduate itself. Very few institutes, we can count the number of institutes in K6 level. So based on this, for example, if you ask me which is the better institute in Tamil Nadu for ECE, everybody can easily understand. In Tamil Nadu, the Thearajar College of Engineering is the best institute for ECE. The reason is their competency level is, the staff member, those who are working in that particular department in TCE's competency level is better. They are doing a lot of projects, funded projects. They are giving those projects to the students in the UG level itself. Then automatically the knowledge level of the students will go high. This is what the basic understanding for every department must be understood. For TCE is not generally talking, is TCE is good for all the disciplines? I cannot say that. Only for particular branch it is good. Like this, for every branches, we can name the institutes across India. In the particular IIT, this mechanical engineering better. In IIT Madras, aeronautical engineering better. How they are deciding this? So based on the students' behavior or based on the students' outcome, the student outcome depending on the knowledge levels, whether they are coming out with K5 or K6 or K4. So normally in the across India, in autonomous institute, they are teaching till K4 maximum. That too, very few number of institutes. In K3 level, more or less all the institutes are teaching. See, please try to understand what is the meaning of this course outcome and the knowledge level. Based on the action verb only, we can easily understand what level it is, what knowledge level it is. Because based on the knowledge level only, we have to ask the questions. Right. The first, I am coming to the samples. Now you can understand. Suppose if you have any questions, please ask me then and there. Calculate major and minor losses associated with the fluid flow in piping networks. For example, this is the subject or a course related with your mechanical engineering or civil engineering subject. Calculate major and this is a prefix statement is after completion of this particular unit, the students will be able to calculate major and minor losses associated with fluid flow in piping networks. Action verb is calculate. Calculate is action verb related with your K3. K3 is apply level. Knowledge, major and minor losses associated with the fluid flow in piping networks. This is actually knowledge. So knowledge part is there in this particular CO. Action part is there. Condition and criteria part is not there. This is optional. These two, condition and C, both the CCs are optional. So this is one example for a simplest course outcome. Very clearly mentioned, calculate major and minor losses associated with fluid flow in piping networks. Very simple. Knowledge is there, action verb is there. So when we look at this statement, we have to understand the teacher, being a teacher, has to understand how much we have to take, at what depth we have to take this syllabus, what type of questions we have to ask. Whenever you, before framing or after framing this CO, we have to write few number of questions for measuring this particular outcome. Without writing the questions, we cannot measure the outcome, how the students attain this. We cannot understand, or we cannot find out how much attainment has been arrived without questioning. So that's what I am telling. All the course outcomes must be smart in the sense, S for specific, M for measurable. Measurable is you have to ask the question, he has to answer the question. If the question is right, the maximum attainment. If the question, if only 50% of students answered this particular CO, only 50% attainment. We have to fix the threshold. This is what the NBA accreditation process you would have understand. All right, sample 2. Look at this again. One more statement from physics. Determine the dynamic unbalanced conditions of a given mechanical system of rigid bodies subjected to force and acceleration. This is the course outcome written. Determine the dynamic unbalanced conditions of a given mechanical system of rigid bodies subjected to force and acceleration. Action verb is determine. Determine is in K3 level, apply level. Knowledge is dynamic unbalanced condition is the knowledge given to. It's in your RBV taxonomy. This is actually called as conceptual and procedural. This is one more taxonomy like Bloom's taxonomy. This is for your cognitive levels, subdomains of cognitive, conceptual and procedural level. It is given dynamic unbalanced condition, and the condition is given. This particular system must be operated, given mechanical system of rigid bodies subjected to force and acceleration. Rigid bodies subjected to force and acceleration. Is there any criterion? No criterion here. So 3 parameters in this particular CO. Action is determined. Knowledge is dynamic unbalanced condition. Condition they have given in the given mechanical system of rigid bodies subjected to force and acceleration. This is second sample. Hope you can understand now. If you have any doubts, please ask me after seeing this third example. Sample 3. Understand the effect of all the parameters in voltage controlled oscillators through simulation using TINATI. This is from electronics or electrical department. Understand is a verb. It is the action verb is understand. This particular CO is written in the first level, K1 or K2, they have written this because understand is the keyword. The effect of all the parameters in voltage VCO through simulation using the TINATI. Look at this. Knowledge is effect of the parameters in voltage controlled oscillator. This is the knowledge concept we are going to give to the students. And the condition is using the simulation by the tool TINATI. It's a tool like you name any tool. Using simulation using TINATI. Criterion they have given, no criterion have been given here. So again 3 parameters in the sample. AKC is available, one more C is left out. I come to the sample 4. This is from mathematics, numerical methods. Determine the root of the given equation accurate to second decimal place using Newton-Raphson method. This is the CO written. The students will be able to determine the root of the given equation. If you give a equation, the students can easily determine the root of the given equation. Accurate to second decimal place. 2 decimal places accuracy precision they can calculate using Newton-Raphson method. Look at the parameters here. Action is determined. So they are determined. When they use the determined, this is K3 level, apply level. Knowledge is root of the given equation. This is the concept we are trying to give to the students. Root of the given equation, conceptual and procedural. Condition is using Newton-Raphson method. Many methods are available, but using Newton-Raphson method is the condition here. Criterion, accurate to 2 decimal place. Second decimal place accuracy we need. This is the criterion. You can look at this sample 4. Determine the given equation accurate to second decimal place using Newton-Raphson method. Action is determined at K3 level. Knowledge is root of the given equation. Condition is using Newton-Raphson method. Criterion, accurate to second decimal place. All the 4 parameters are available in this equation. Sorry, in this course outcome. So if you write this clear-cut course outcome, then everything will be easy for us. We can easily, whoever may be, there are some n number of sections, 4 number of sections in the for the second year students. All second year students may have the same subject, same syllabus. Now the teachers are different. When they go easily by going through this statement, each and every teacher can understand. So we have to teach the students to find out the root of the given equation in 2 decimal place accuracy using Newton-Raphson method. This is what we need to require. So there is no ambiguity in the statement. Ambiguity is totally removed. So no ambiguity. So it is very clear. And the question also, assessment part also, they have to ask the students, the staff member have to ask the questions till apply level. Apply is K3 level, knowledge level. They have to ask the question in that sense. We can solve many number of questions in the classroom. We can solve many number of real-time questions in the classroom. Apart from this, if you ask one more question, not from the classroom worked out problems, if you ask one more question, the student should write the answer for this given problem question. This is what the meaning of apply. If you ask the question in the classroom, same without changing anything in the question, if you ask the same question in the end semester examination, if the students is deriving the equation, that is not apply level. That is again K2 level, not in K3 level. K3 level is the same kind of problems we have worked out in the same scenario or in some other scenario, a new scenario. We are giving the problems to the students while assessing or setting the question paper. The students has to understand and apply the problems whatever they have learned in the classroom. They have to solve this answer, solve this question. This is what the expectation. This is in K3 level apply. So whenever we start this, whenever before going to the class, we have to first of all go through the syllabus, then course outcome must be gone through. Only then we can understand how good we have to, how depth we have to take this particular subject. It's top level or in the root level we have to go get into. So actual syllabus is your breadth. The CO is your depth. CO, from the CO only we can understand how depth we have to go. So only then we can assess the students in right sense. Is the same syllabus, same thing. If that statement can be written for K4 level also, but your content delivery is in K4 level, then you can ask a question in K4 level, analyze level. So analyze level is little more advanced. Their cognitive sense must be used. The students' cognitive sense must be used here to solve the problems. An entirely different problem will be asked in the question. Not the same problem, whatever they have given in the textbook or reference book or in the classroom. Something new we have to ask. This is what sample 4. From these 4 samples, I hope you can understand what is the meaning of course outcome and what are all the differences and what are all the parameters in every course outcome. This is first one. Only 2 action and knowledge are 2 parameters are available. This is second one. Again, this is second one. 3 parameters except the criterion. Remaining 3 parameters are available. Third sample, again 3 parameters are available except the criterion. Fourth sample, all 4 parameters are available in the same course outcome, but different subject. So being the subject matter expert, you have to understand what extent we have to teach to the students. And based on this understanding, a group of teachers, those who are handling the same subject, have to write this course outcome. Hope you can understood. Now, if you have any questions, please ask me now itself. I can move on to this another one part or little more depth using electromagnetic theory. If you have any questions, you can ask me right now. Okay. Now I move on to this next, the same course outcome, but different. For the unit, we are going to, for example, this is the syllabus for electromagnetic field in regulation 2017 of Anna University. Electromagnetic field, electromagnetic model, units and constant, review of vector algebra. They have given in the syllabus itself a review of vector algebra. This is actually remembering. The review is a remembering part. Remembering is your K1 level. Rectangular, cylindrical and spherical coordinate system, line, surface and volume integrals, gradient of a scalar field, divergence of a vector. Like this it's going. It is curl, Stokes theorem, null identity, Helmholtz theorem. All these things are in the first unit. For the same subject, the second unit, full of law, electric charge, Coulomb's law, electric field due to line, surface, volume densities, electric flux. The basic definitions, the basic laws are available in the second electrostatics. Next is magnetostatics. This is the Lorentz force equation. Again, magnetostatics laws are coming. The basics are coming. More or less, all these are all equation. Magnetic field, vector potential, Lorentz force equation, magnetic circuits, behavior of magnetic materials, CRT, magnetic deflection, magnetic. So this CRT is the application of this magnetic statics. Magnetic deflection, we have to explain by using CRT. Magnetic brake, this is one more application. Linear motor is one more application. These are all different applications. In the second unit, in the last two lines are more or less applications of magnetostatics. All these you have to, so from this, from whenever you go through the syllabus for all the units, after reading all the 5 units or 4 units, whatever the number of units you have in your syllabus, you have to write the abstract of the syllabus. These theorems are dealt in the first unit, or the first and second unit theorems are basic theorems are there. Second unit is full of electrostatics. Third unit is full of magnetostatics and in 1 or 2 simple applications of magnetostatics. Like this, you have to write the abstract. Fourth unit is the time varying fields and Maxwell's equation. This is full and full Maxwell equation and time varying fields. They are calculating group velocity, electromagnetic power flow and Poynting vector. All these are there. The students can be able to calculate or able to solve something like this. You try to here. And fifth is waveguides, rectangular and circular waveguides, something like this they have given. And the TE modes and TM modes, all these 2 different modes are given. Next is TEM modes in the rectangular waveguides. Why it is not impossible? Why it is not possible in rectangular waveguides? Everything they have given in the 5th unit. Now I come to this part. Listen, here you can ask the questions somewhere. This is actually the syllabus from IIT. One of the IIT and 2 different NITs are having the same syllabus. For first course outcome, I am trying to write, apply fundamentals of vector analysis and 3D coordinate system. It is in K3 level. See, look at the first unit syllabus. First unit, full and full, the basic items. It is a recap of the previous prerequisite. For the coordinate system, we have to understand that is from the spherical coordinate, rectangular coordinate from your mathematics part or physics part. And electromagnetic model is already physics, you would have studied it. These are all the prerequisite of the existing subject. Like this, if you go, apply the fundamentals of vector analysis and 3D coordinate system. The given is K3. This is, as such, I have taken this example from NIT. K3 level, they are conducting this class, or this particular, the first unit is taught by the staff members of NIT in K3 level. K3 is applied. So apart from the questions, whatever they are dealing in the classroom, they are explaining in the, they have explained in the textbook or reference book, some new examples or new problems. If you ask to the students of that particular institute, they are capable of handling, answering this question. This is what the depth they go given. K3 level, they have written this. So that teacher has to handle this session for this first unit till K3 level, not K1 and K2 level. K1, K2 is essential. Automatically K3 level, 1 or few questions they have to, the students will be able to answer or solve because it is written in K3 level. Second, CO2, review the basic concepts of law in electromagnetics. They have written They have, this is electromagnetics. Review the basic concepts and laws in electromagnetics. They have very simply, they have given review. Review is the keyword or the action verb for your knowledge level 2, K2. K2 is understanding. So review the basic concepts and laws in electromagnetics. Simply they have written. So only the recap we have to give, that is K2 level, not in K3 or any other level, K2 level. Very basic level, K1 or K2 level, they have written this. Third is, course outcome 3 is, compute the field quantities based on the concept and laws. Compute the field quantities. So compute in the sense with the students have to compute, have to solve the problem, or the field quantities have to computed by the students based on the concepts and laws taught in the previous unit or previous CO. When you do like this, K3 level they have given this compute, because the compute is the action that they have given. K3 level they have given. K3 level is the students are capable of computing the problems out of the book also. If you give the same problem to your students, they'll be telling this is out of syllabus. Because we are not taking this problem in our regular classroom as well as in the notebooks, as a textbook or your reference books also, it is not available. Then automatically it is going to the category of out of the syllabus. No, it is not out of the syllabus, because CO3 is already given in K3 level. Some other problems away from your subject or regular teaching should be asked to the students to find out their capacity or cognitive level. So they have to answer, they have to in a position to answer those kind of questions. If it is not there, we should not give K3 here. K2 only we have to give. If the students are, if you know the quality of the students, you are telling the IIT students are better quality, so the achievement is better, outcome is better. But if your students are not good, don't go to K3 level, K2 level without knowing the, based on the audience only. Even though whatever you know, being a teacher, whatever you know, you should not teach to the students in your own level. This is not students staff centric or the teacher centric curriculum. This is student centric curriculum. For the students only we are teaching, and at what level they are. So based on their level we have to teach. It is, otherwise it is not useful to them. If you talk in different language, if they are not understanding, definitely what is the benefit of teaching? Nothing will happen. Teaching will not happen in the classroom. So to the student level, we have to deliver the content. If the students are very good, creamy students, we have to give this syllabus in K3 level. This NIT, they have given this K3 level. If you take the same syllabus, if the students are not, they are not so good, so K2 level itself you have to complete. Then gradually we have to improve this. In the beginning semester, K1, K2 level. In the next semester, if there is any other, say for example, continuation of electromagnetics, maybe as a subject of antennas and wave propagation or transmission lines and waveguides, you can teach them in K3 level for those two subjects. Being a prerequisite, this subject will be in K2 level, maybe in K2 level. Nothing wrong in that. But being the subject matter expert, you have to understand what are all the things we have to deliver to the students based on the quality of the students and based on the content delivery, based on the knowledge level, whatever you have given in this course outcome. Next, CO4, course outcome 4, examine the behavior of materials in the electric and magnetic field. Examine the behavior of materials in electric and magnetic field. It is given in K4. Look at, see, we are struggling in K3, but they have given examine the behavior of materials in electric and magnetic fields, K4. Examine the behavior of the two different materials they have taken as a case study in the classroom. They can ask a third material also, which we have not dealt in the classroom. They have given this. So K4 level is analyzing level. Analyzing level is better than your apply level, K3 level. It is K4. So the students, the content delivery must be in that sense. The teacher should initiate the analyzing capacity of the students. Only then we can put in K4 level. And CO5, derive Maxwell equation. This is very simple. Derive Maxwell equation is K2 level. And wave equation for static and time varying field. Derived Maxwell equation and wave equations for static and time varying field is in K4 level. K4 is analyzing for different scenario, for different field, for different mode. We have to write this Maxwell equation and wave equation. We have to derive. the students have to derive. We can give 1 or 2 samples. From these samples, the students have to, they should be able to derive the new equations for new scenarios. If it is so, that is analyzed. So the students have to analyze the scenario and they have to write or derive the equations using Maxwell equation. The wave equation should be derived using the Maxwell equation concept. This is K4 level. K5 level is also. So that's what I told. Very few institutes in India is giving the UG level programs in K5, K6 level. K6 level I never seen, but K5 level, few institutes I can show you. K4 level, some more institutes we can show, but normally across India, the level of the UG students in engineering is K3. Discuss propagation of electromagnetic waves in lossy and lossless medium. This is K5 level. This is ultimate level. K5 level is, this is some more evaluation level, or we can call it as creating level, creativity level. We can interchange in this Bloom's taxonomy. 5 and 5th level, 5th and 6th level can be interchanged in Bloom's taxonomy. So they have to evaluate the scenario. They have to create a new scenario and evaluate it. This is discussed propagation of electromagnetic waves in lossy and lossless medium. This is what all 6 COs written for the given syllabus. If you give the syllabus in the same sense, if you are not capable of giving K4, K5 or even K3, you have to change it into K1 and K2. But based on this, you have to ask the questions. You have to access the students. This is what the idea. Now I come to the conclusion more or less. Rules for framing the course outcomes. CO shall be framed for the entire course, not for your unit. For the entire course, you have to frame the syllabus, course outcome, not for units. You can understand what language I am talking now. Unit wise, if you write maximum 5 course outcomes, we can write. But if you write for the entire course, based on your requirement, you can write either 4 or 5 or 6, whatever the number you. According to NBA requirements, 4 to 6 number of outcomes we have to write. 4 to, depending on, you have to defend the committee and you have to explain, justify why you have selected 4 number of outcomes or why you have selected 5 number of outcomes, or there is a method for this known as a concept map. I will show the screen. Concept map. Based on the concept map, we can easily identify how many number of COs we have to frame for this given syllabus. And number of COs need not be fixed. It can be 6, 4, 5, whatever it is. Need not be a fixed one. But CO statement must be smart. Smart is specific. It should be very specific, measurable, achievable, realistic, and time bound. Within the 9 hours, you have to complete one CO1. For example, they have given for the entire course 45, 3 credit course, 45 hours. You have to complete it in 45 hours, not more than 45 hours, because the hours will not be available. Statement shall be framed using Bloom's taxonomy. For your understanding, I can say, for the theoretical courses, you can go with Bloom's taxonomy. For the practical courses like laboratories, you can laboratory and projects, you can go with the Dave's taxonomy. Dave's taxonomy is good for your practical courses. Even K5, K6 can be easily handled there, whereas Bloom's taxonomy for your theoretical courses. And these are all the different verbs. Remembering is K1, understanding is K2, applying is K3. This is your Bloom's taxonomy. Evaluation is K5, creating is K6. This is what your 6 levels of knowledge. And the same thing is repeated. Do's and don'ts. While writing your COs, don't use the words like, such as, different, various. The vague words should be avoided. Many number of ways, different kinds of, various types of, such as, like. These are all avoided. We need not use this, because if you use that one, it will not be specific. If you use those kind of words, it will not be specific. Your COs will not be specific. So enumerate all the relevant knowledge elements one by one. Next is put in effort to make CO statements as detailed as possible and measurable. Do not make it either too abstract or too specific. Too abstract and too specific. Checklist. Action verb is there, you have to find out. Knowledge terms are there, you have to find out. Learning process is available, criterion is available, you have to find out. I come to this within this 10 minutes, I can complete with the concept map. More or less 10 minutes more, within the 10 minutes, we can easily complete it. For example, for engineering mathematics 2, I can, engineering mathematics 2, I can divide this. Say these are all the first level is actually, this is actually called as concept map. In this concept map, the engineering 2, mathematics 2 deals with multiple integrals, Laplace transform, vector calculus, analytical functions, and complex integration. This is what 5 units I think they have given in that syllabus. First unit deals with maybe dealing with multiple integrals. Second unit Laplace transform. Third unit vector calculus. Fourth unit analytical function. Fifth unit complex integration. These multiple integrals are used to evaluate double integral, triple integral, volume of area of a plane and volume of solid. The Laplace transform are consisting of transforms of elementary function, inverse Laplace, solving, and vector calculus is including vector differentiation, vector integration, 2 different. So with this, if you find out many number of subdivisions are coming out. So if you want, according to this, they have given this for engineering mathematics, this level is 5 units or 5 outcomes they are trying to write. 5 outcomes they are trying to write for the entire syllabus. Don't say when I say 5 outcomes, unit wise one. This is not the case. One say, I don't know exactly, without seeing the syllabus, I cannot say anything about that. Analytical functions may be written in 2 units also. Nobody knows. But they have given. So as a whole, we have to find out how many number of subdivisions we can make. So those subdivisions and content and delivery number of hours must be equal, more or less equal to all the COs. Only then we can make it as a separate CO. So 4 to 6 number of COs maximum we can write, but not in unit wise. If you say unit wise, it is wrong. So this is what the based on this, they have given this COs. And I come to the last part. Within 5 minutes, I can complete this. Once if your syllabus is completed, CO is framed, how effectively we are going to assess your students, evaluate your students. This is assessment pattern for continuous assessment test 1, test 2, test 3, and end semester examination. Remember how many number of marks or percentage you are going to. This is, for example, marks. Apply level in the CAT 1, we are going to ask 60 number of marks, 60, 30, and 10, totally 100. Look at this. In CAT 1, remember, so we cannot ask any question in analyze, evaluate, and create level. We cannot ask any question in the analyze, evaluate, and create level. So your COs should not be in K3, say K4, K5, and K6. Only 3, K3, maximum K3 will be there in your CO. In CAT 1, we are going to ask this kind of apply questions with 60 number of questions in apply, 30 number, not questions, 60 marks for applying, 30 marks for understanding, 10 marks for remembering. For CAT 2, more or less the same. CAT 3 also same. And end semester, apply level, we are asking 70, understanding level 20, remembering level 10. Now you can ask me why it should not be equal. Remember is 30, understanding is 30, and apply is 40. Why it should be apply level is 70? When you increase the knowledge level of the students, only then we can ask the question in 70 number of 70 marks for in the final examination, end semester examination from apply level. Only then the quality of students will increase. Teach them well in K3 level, ask them well questions, well oriented questions, not the same questions. The basic difference between state board education and the CBSE board education. In state board education at school level, they are touching only K1 and K2. But in CBSE level, NCERT syllabus, normally they are touching K3 level. They will be teaching one thing in CBSE classroom, and they will be asking the same kind of related application level question in this examination, final board examination in this. So the K3 level they are asking in CBSE. The same thing we have to do. If you increase the knowledge level in a content delivery and assessing, the quality of the students will be better. Your students will also crack the GATE examinations. Many number of last year 10, this year 20, next year 35, something like it will go high. One fine morning after 5 or 6 years, somebody will be saying in that particular colleges, this college in particular department is better. Reason, the students are placed well. The students are cracking the GATE examination well. The students are placed in Magaratna companies, Navaratna companies, government examinations cracking well. So this is what the understanding. This is what the identification whether your department is good or not. So if your students are capable of cracking the GATE examination, their understanding level is better, applying level is also better, analyzing level is also better. If you teach them only K1 and K2 level, how they will crack the examinations without understanding, apply and analyzing? That is what the understanding. So if you want to improve the quality of the students, you have to improve, you have to write a quality course outcome. Once your course outcome is quality wise better, then everything will be better. But it will not happen over the night. It will take 1 year, 2 year, 3 year, 4 years also to get the outcome. One batch of students with the proper course outcome should go out. Only then we can find out the outcome, how good our students are. With this, I want to conclude this session. I have a lot of other slides and concepts of maps also. Even then, due to the time constraint, I want to close this session right now. Thank you so much. Thank you. If you have any questions, please ask me now.
Participants, if you have any questions, you can ask regarding the course outcomes and other delivery.
Yes, sir. Good morning, sir.
Good morning, sir.
Sir, any action verb it is suited for psychomotor domain?
Psychomotor, normally psychomotor activity based learning only psychomotor level can be implemented. Instead of trying to implement the psychomotor level in the theoretical session, for example, theoretical session, the major problem is the number of conducting hours. The contact hours are very minimum, only 45 hours for 3 credit papers they are giving, maximum 60 hours for 4 credit papers. Only in the tutorial classes and theory practical oriented classes, you can improve the psychomotor level questions. Psychomotor can be classified, can be put in either K3 level or K4 level.
Yes,
depending on the work or quantum of work or understanding of the work.
Yeah. So we have a lot of practical courses in our undergraduate curriculum. We want to combine this theory part. For example, you mentioned the one fluid mechanics subject in mechanical, and we have separate lab. Now we want to integrate and made
both theory with laboratory.
Single subject. At the time, we need to
unit will be laboratory experiments will be there, and 4 units will be normally theory subjects.
Is it okay, or otherwise we will
normally this is the fashion. There is no subject like theory with the practical, sir. Okay. The problem is actually where it comes. The AICTE model curriculum, they have restricted our credit only to 165 for mechanical engineering.
Yes, sir. Yes, sir.
Within the 165, you are not knowing which subject we have to keep, which subject we have to throw out. Okay. Because all the subjects are your fluid mechanics is very much essential. You are feeling this is a core subject for mechanical engineering. Yes. Your material team science, or that domain also, they are thinking this is very essential to the mechanical engineering. Okay. So in that problem, they are mixing the theoretical part and practical part. According to my knowledge, keeping the separate theory, keeping separate laboratory will be good. That will improve the understanding of the students. I mean, cognitive level of the students better. Okay. Psychomotor level will also be increased. Because laboratory sessions are normally activity based. It is not theoretical understanding, something like that. Activity based. You let the students do the work, to do the experiments. Then will be psychomotor will improve.
Okay, sir. Sir, any tool for preparing this concept map?
Concept map, a lot of online tools are available, sir. Okay. Lot of, you Google it in open Google itself. For the concept map, a lot of tools are available. Lucid chart is one of the easiest tools. Lucid, LUCID.
Okay.
Lucid chart.
I will check, sir.
That is a free version. It is useful to you. But over the period of time, if you work in this CO creation, CO drafting for 1 month, after 10 days, if you go through the same statements, you can find out, oh, this is what we have done the problem. After 10 days, if you improve the understanding of writing COs, then after 20 days, if you sit and read the same statement, whatever you have written 10 days earlier, it may be blunted to you.
Okay.
Because in that sense only it will be evolved. Then our ultimate aim is, if you write the quality CO, your quality of the students will be better, not on a single night. Overnight, nothing can be changed. A period we have to wait. One batch, 3 years, 4 years, we have to wait.
Actually, in the curriculum, now we are telling at OB, right, sir?
Outcome-based education.
For which we, first of all, we need to prepare the assessment questions first. Based
That's
on
what
the,
in my, do you able to see my screen, sir?
yes, sir.
Yes, sir. Now the questions, this is for control system. Control system is common for all.
Okay.
First, whenever you find out.
Thank you. Thank you. Slide is visible to us.
Oh, one second. I will now.
Yes, sir.
Now, if you look at this, these are all the control system questions.
Okay.
So we have to prepare whenever you write any CO.
Okay.
In part A, how many number of questions you will be asked? You will be asking. You have to prepare for part A questions, part B, part C also.
Okay.
So in different knowledge levels, you have to, if the CO is written in K3 level questions you have to give. Whether this question can be answered by the student. Even many number of universities, many number of autonomous institutions now started a fashion of open book examination. See here, open book examination question.
Yes, sir. Yes, sir.
This is the syllabus taken from GMR Institute of Technology, Rajam.
Hyderabad, right?
Not Hyderabad. It is our Srikakulam, Andhra Pradesh.
Okay. Okay.
Rajam is the place. GMR Institute of Technology. This is, they have given very clearly open book examination. Even though you give the book to the students, this question cannot be answered as such.
Oh, okay. Okay.
Only they can get only the what we call equation from the book. Nothing else they can take, because this problem is entirely new.
Okay.
So whatever you taught in the classroom, if they understand very good, only then this problem can be solved. That is sure.
Yes, sir. Yes, sir.
So if you improve that kind of psychomotor or cognitive level of thinking order, definitely your students will be going good. Definitely, whenever this control system question is answered by your students, he will definitely crack gate. No doubt in that.
Okay.
We are increasing the analyzing capacity of the student.
Yes, sir. Yes.
Questions must be prepared, sir.
Oh, yeah.
Parallelly, whenever you look at your syllabus.
No, sir. For preparing questions, we need input from industries also, right?
Stakeholders may be many, not only industry. You can ask your alumni students, those who have already cracked and worked in industry.
Yes,
you can take your inputs from your senior fellow members, those who have handled the subject previously.
Yes,
all kind of inputs can be collected. Only then we can come to the quality CO. CO writing, CO is a small sentence, but it will not be written as such in a single moment.
Okay.
It will take time.
Yes, sir. Yes. Thank you, sir.
Thank you, sir. Thank you.
Any more questions from participants?
Okay, sir. Thank you.
Okay, sir.
Thank you very much, sir.
Thank you, sir. Thank you, sir. Thank you.
So I thank Dr. S. Rajarajan sir for his excellent presentation. Of course, sir has given many things to write the course outcome, how to write the course outcomes, and he has given a crystal clear presentation about the course outcomes with the examples also, and he has explained the Bloom's taxonomy and the knowledge levels, how to take the things in writing the course outcomes, and how to consider the knowledge levels and other things. And also he has explained what are the things we have to do and do's and don'ts. And also sir has given many examples with the question papers, and how to set the questions and how to improve the quality of the students, the knowledge level of the students. And on behalf of Sri Sai Ram Institute of Technology and the Indian Society for Technical Education, Thank you for your excellent presentation. Thank you, sir.
Thank you, sir. Thank you so much. Being a part of your Sairam Institute of Technology and this ISTE refresher course, I thank you very much because you have taken a lot of pains to conduct this ISTE refresher course. And Shanmugh Sundar sir, thank you very much, sir,
Thank you, sir.
for your kind support and wonderful sessions arranged by many number of participants. Thank you, Saravanan sir. Thank you so much, sir. Thank you all.
Thank you, sir. Thank you, sir.
Thank you. Can I leave the meeting, sir?
Yes, sir. Yes, sir.
Thank you, sir.